Water plays a crucial role in shaping our environment, and one of the most fascinating processes in hydrology is infiltration. But what exactly is infiltration? Why is it so important, and how does it affect the water cycle? In today's video, we'll dive deep into the science of infiltration, exploring its definition, factors that influence it, its role in hydrology, and real-world applications. Infiltration is the process by which water on the ground surface enters the soil. When it rains or snow melts, some of that water flows over the surface as runoff, while the rest infiltrates into the soil. This process is a critical component of the water cycle as it helps replenish groundwater and provides moisture for plant roots. The infiltrated water moves downward through the soil layers, eventually reaching the groundwater table, where it contributes to aquifers. Infiltration not only sustains life on land, but also plays a vital role in regulating surface water levels, reducing runoff and preventing floods. Now, let's explore the factors that influence infiltration. The rate at which water infiltrates the soil varies depending on several key factors. Different soils have different infiltration capacities. Sandy soils with larger particles and more pore spaces allow water to infiltrate quickly. On the other hand, clayey soils with their fine particles and limited pore space have a much lower infiltration rate, causing water to pool on the surface during heavy rainfall. The amount of water already present in the soil affects infiltration. Dry soil can absorb water quickly, while saturated soil has little capacity to take in more water, leading to surface runoff. Vegetation plays a significant role. Plant roots create channels in the soil, increasing its porosity and infiltration rate. Additionally, vegetation helps reduce the impact of raindrops on the soil surface, preventing compaction and enhancing infiltration. The slope of the land also matters. On steep slopes, water tends to flow quickly, reducing the time available for infiltration. In contrast, on flat terrain, water tends to pool, allowing more time for it to infiltrate. Finally, the nature of the precipitation itself affects infiltration. Light, steady rain is more likely to infiltrate than heavy, intense rainfall, which often exceeds the soil's infiltration capacity, leading to runoff. To quantify infiltration, hydrologists use various methods. The most common tool is the infiltrometer. There are two types, single ring and double ring infiltrometers. The double ring infiltrometer consists of two concentric rings inserted into the soil. Water is poured into both rings, and the infiltration rate is calculated by observing how fast the water level drops. This method minimizes lateral water movement, providing accurate infiltration rates. Other advanced techniques include using lysimeters, which measure water infiltration, evaporation, and transpiration over time. These tools are crucial for accurate water management strategies in agriculture and urban planning. One of the most widely used mathematical models for infiltration is Horton's equation, which describes how infiltration rates decrease over time during a rainfall event. The equation is Ft is the infiltration rate at time t. FO is the initial infiltration rate, F_C is the final or steady-state infiltration rate, K is a decay constant that represents soil characteristics. Initially, the infiltration rate is high as dry soil absorbs water quickly. Over time, the rate decreases and stabilizes as the soil becomes saturated. Horton's equation helps predict infiltration under various conditions and is widely applied in hydrological modeling. Infiltration is a cornerstone of hydrology, playing a vital role in groundwater recharge, flood prevention, and soil health. By understanding the factors that influence infiltration and using tools like infiltrometers and Horton's equation, we can better manage water resources and mitigate environmental challenges. If you found this video informative, give it a thumbs up, share it, and subscribe for more content on hydrology and water management. Let us know in the comments if there's a specific topic you'd like us to cover next.